So welcome to another River Publishers discussion. My name is Philippa Jefferies, and with me I have Nicki, another editor at River Publishers. And we are pleased to introduce Vijay Sood, our new editor for our series Empower and the Distributed Generation and Alternative Energy Journal. He is an associate professor at Ontario Tech University and has experience in HVDC transmission systems, control and protection of power systems, and a lot more, I'm sure. Today, we're going to talk a little bit about his research interests and experience, as well as the book series and the journal. So Vijay, Nicki, thank you so much for joining me today.
Oh, thank you for having me.
So Vijay, could you start by talking a little bit about how you got started in this area and your kind of research focus that you have now?
Sure. I started out in power electronics when I graduated. And my first introduction to the industrial world was to develop DC choppers for electric trains. And that was my introduction. So I started out with British Rail in England and in Derby. So we were developing a fast high-speed train over there. And the power transmission system, the power train was a DC chopper at that time. And we built the first locomotive with thyristors on the train.
Okay,
and,
really?
It was very, very interesting at that time, and we had a lot to learn about power electronics and how they managed to work with the transportation industry in those days. So that was my first introduction, and then I moved from there onwards to Canada. I came and joined Hydro-Quebec at the Research Institute, and we started looking at high voltage DC transmission. So it was a jump from 5 kilowatts to 500 megawatts.
Wow!
It was quite a transition, but the fundamental principles were the same. So that was how I started with high voltage DC transmission. And Hydro-Quebec wanted to build a line from James Bay up north, all the way down to Montreal and further down south into the United States. And we started looking at that. And so there was a lot of development work to be done looking at this line. It was a very high voltage, 500 kilovolts, plus and minus. It was at 2,000 megawatts. So that was a jump from existing technology. And of course, we really took it to the ultimate, and we decided to have 5 terminals instead of having just 2 terminals everywhere else in the world. So 5-terminal high voltage DC transmission system was unheard of in those days. We eventually settled on 3 because trying to manage and control 5 terminals at the same time was just too much of a tall order. So we ended up having just 3, and we brought in 2,000 megawatts from James Bay all the way down to Boston in the US, or close to Boston. And that high voltage DC line is a 3-terminal, multi-terminal system right now, which is probably one of the largest in the world. And it's earning its keep. It's earning its keep right now. So, and then I decided, to move from industry into a university environment, because I wanted to do some research and look into what became the new buzzword called the smart grid.
Yeah.
So high voltage DC transmission technology became installed into the smart grid area. So we use converters to bring in new renewable energy to connect to the grid. And the same technology was used, but it was applied to a different area right now. And that was the buzzword 15, 20 years ago. I came in 2007.
It's still a buzzword, really.
It still does very well, of course. That was the same thing with the high voltage DC transmission. We used to say, oh, high voltage DC transmission is coming in 5 years or 10 years or 15 years. And then when we blinked, high voltage DC was all over the world.
Yeah.
Yeah.
You know, in China, in India, in South America, you name it, it's there. And it's all over right now. So the same thing is going to happen to the smart grid in the next 20 years. The smart grid is going to be, well, what we think is going to revolutionize the way we use electricity. And our lives are very much tied into that. I mean, you know, electricity is something that we use every day. And without that, you know, you just can't imagine what's going to happen without that. So it's going to be fun. It's going to be a great deal of fun going forward, you know.
Yeah, I think that that move from electricity being generated in one place and moved to somewhere else, the big change is now electricity being generated anywhere and fed into the grid anywhere. But those same technologies have allowed it to work, allowed it to be to not lose power through the system, and that. And this journal, the Distributed Generation and Alternative Energy Journal, is a 37-year-old journal. So it's not like as if distributed generation and alternative energy weren't kind of things that people were thinking about even in the 80s. They were thinking about it in a different way than the kind of technologies Vijay's been involved in, which have then allowed this to be much more applicable at a kind of really
And the paradigm shift, of course, took place because of climate change. People suddenly began to realize 20 years ago there is something called climate change happening. And we have to start thinking about the planet, because otherwise there is going to be environmental damage and all kinds of other consequences that we have to live with. As a result of that, we have to rethink the way we use energy. The fossil-based energy is now a thing of the past, or will be a thing of the past, because we just cannot afford to burn that fuel. The damage that it's doing to the climate is just too much and too severe.
Yeah, climate change definitely is like kind of the topic of the moment, especially with COP26 and everything this year. Many nations are setting goals for emissions and use of fossil fuels and things. What do you think, kind of moving on from that, what is kind of the biggest thing that we can be doing though, when it comes to power grids and transmission systems, smart grids? Like, how can we kind of help reach our goals?
The biggest change is going to come because the generation side, you know, the smart grid is going to involve everything. It's going to involve generation, it's going to impact the transmission, and it's going to impact the consumption side. So it's going to impact everywhere. It's going to, you know, start from the generation side, because we're now going to utilize renewable energy. And renewable energy, you know, in whatever shape or form that you look at, is all going to be coming from the sun. You know, whether it's wind energy or whether it's biomass, it's all eventually down from the sun. You know, it's power or energy that's coming down from the sun. We can go through transition stages in between, convert that energy into carbon if you want to, or even fossil fuels, but it's still coming from the sun originally. So it's going to be renewable energy, in which case solar and wind. And wind is solar energy if you look at it, because wind is caused by the sun and temperature differences. It's directly related. You know, whether it's solar or it's wind or some other form of energy, we are going to install that energy into the grid closer to the consumption areas, in which case we are going to reduce the losses inside the transmission. So the transmission losses are going to be taken out of the picture, meaning that we're going to have a much more efficient utilization of that energy, where we need it, when we need it, and so forth. So that's going to be a paradigm shift.
What are the big challenges, though, in that connecting?
The biggest challenges, of course, is now the biggest problem is the grid that we know today is it's got two characteristics. One is constant frequency, and the second thing is constant voltage. But the renewable energy is coming online. They are intermittent. They are not consistent with the way we utilize energy, constant frequency, constant voltage. So with wind, it fluctuates all the time. With solar, it's there sometime and it's not there other times, and it varies all the time. So we have to have something in between those two extremes. And that's the power conversion stages. And thanks to power electronics and recent developments within the last 50 years, I think the first thyristor came out in 1957 or thereabouts. So this is, power electronics has been around for more than 50 years, but now it's become a real game changer for the way we utilize energy. So that conversion now becomes very, very important. How we connect that intermittent variable source of energy into a grid which is constant frequency, constant voltage. Once the conversion is done, we still have to worry about something called inertia, because the frequency of the grid is constant. And that was kept constant because we had this massive big grid, what we call the infinite grid, which kept that frequency at a constant level. But when we start connecting these intermittent sources, there is no inertia behind them. In the case of synchronous generators, we used to have massive big inertia, which could maintain the frequency. But now with renewable sources, because there's no inertia, there's no way to keep that frequency constant. So we have to utilize electronic means now to generate what we call virtual synchronous machines. So these virtual synchronous machines will now become very important to maintain that frequency constant.
And Vijay's storage link to that is the ability to be able to store this energy and feed it back in.
You hit the nail on the head over there. That's going to be, storage is going to be the key issue because one of the fundamental facts about electricity is that we can't store it. We have to utilize it as we generate it. We had batteries in the good old days, but those batteries were very small, and the energy content of those batteries is very, very small. Even today, with the new batteries coming on, the storage aspect is low. But we need that storage to provide us with that continuity in the source that we need. And storage is going to play a big role in the future smart grid, definitely. So there's lots of things happening. Like I said, this new smart grid is going to be impacted on the generation side, on the transmission side, on the consumption side, and now you can add the storage aspect as well. That's going to be the fourth pillar. That's going to look at the smart grid. We didn't have that storage worry in the old days because we had this inertia that could be utilized at the store. But now we need to provide some artificial storage.
We have a couple of special issues for the journal with open calls for papers in exactly these areas, like trends in energy storage and fuel cell technologies. One's on a role of AI in next generation energy storage, and another one on power electronics applications for emerging smart grid applications. And I think all of their deadlines for anyone who's listening are into March next year. So we look forward to getting more papers in those areas.
Yes, thank you very much for that invitation to participate in this area. I mean, this is a very hot topic right now.
Mm-hmm.
There's tremendous amount of research going in there, and this journal offers opportunity to publish or disseminate your information and your research. I should take advantage of this. This journal has a history of 37 years behind it, as you pointed out. So it's a very good journal to disseminate that research.
Yeah, I think so. We can certainly reach more of this cross section between the energy management community and the power generator community, and I think that they're sort of two communities that have been at right angles with each other, but we're at that sweet spot that can talk to both. And I think we've got, Vijay's experience both in industry and academia is exactly the kind of people we're looking to write papers for us. We want applied papers. We're interested in a bit of the theory, but we're more interested in when it actually shows that it works. Like, we want to see it.
Definitely practical. The practical side of things is very, very relevant and important at this point. The theory is definitely there, but we need to have some practical applications that we can look at.
And that's probably the same for the book series, actually, is the same thing. Is I think you're probably finding that less theoretical books, more books showing how, case studies of where things have been implemented.
Yes, that's another great area you've touched on, because now with the availability of the internet and communication is going to play a big role in making sure the smart grid can deliver on its promise. Because without those two aspects, because now we have to talk, the consumers have to talk to the generators at all times to make sure that there is no mismatch between demand and supply. So because of that, we need very fast communications. We need reliable communications, secure communications. All those are aspects of tremendous importance. So the key words here are, again, fast communications, reliable communications, and secure communications. I think those key words have to be out there, and people have to understand the implications that brings to the table.
So for the non-technical listener, that's the things like if you've got your Nest at home or your Google Home thing that controls the temperature of your home, that when you're away or you're outside, you can use your smartphone to just turn the heating up at home or turn the heating up somewhere else. And both Vijay and I, originally from Britain, now in Canada, heating way more important in Canada. Way more important. Like we're going below zero at the weekend, and I don't think we're due to come above zero for the next 10 days then. So it'll just be a long, cold stretch.
Well, again, you've got to think about the smartness of the whole grid. And smartness, becomes very relevant because now you have to have many of these controllers that play a big role in this. The new algorithms that are out there that can control these converters, because now the stability of the grid is very relevant. The grid is going to be split up into what we call microgrids. That's another key word that I'm pitching out there, that people have to understand, that the grid is now going to be composed of many mini grids and microgrids, and controlling all these little grids to function together with the big grid is going to be very, very important, and the control aspect is going to be very relevant. Again, communications is going to play a big role in this. The latency that is inherent in these devices is going to affect the stability of the grid. So we need to have communications that are reliable and secure and fast, so that we don't have that problem.
And that sort of Internet of Things aspect, that things are learning and feeding back, and then learning again and feeding back. And then you add that, before the call started, the official recording started, we spoke about data analysis, big data, and all of that data analytics layer, which then so you're learning while you're doing it, and then you're learning again after you've done it over. So it's one big, huge piece of kind of stuff that we're solving these huge problems, like with millions of pieces of small data.
Yeah, it's going to be interesting because, we are going to create a vast amount of data. Each sensor that we have on the grid is going to generate data. And how we manage this huge amount of data that we are collecting, that is going to be very relevant. So the smart grid is going to employ a lot of experts from a lot of different areas of expertise. It's not going to be just one silo of expertise. It's going to be a multidimensional, multidisciplinary area to look at, and therefore it's an area which is fascinating for the next 20 years. I mean, it's going to, it's going to be an area really to be watching and learning from. So there is going to be tremendous development in this area. If you look at the governments in various countries, the US has just announced almost like $1.5 trillion of investment to go into this new renewable energy generation system. The other governments that you can look in Europe, they are committed to all this. We saw this happening in Glasgow in COP26. All the governments were there predicting in the next, so many 10 years, 15 years, things are going to be very, very different. So there is going to be a lot of money invested in this area. And therefore, we look forward to great inventions and great technology improvements coming in this area.
And great books and articles as well.
Yeah, well, you do, and you've. I think working in this area, River publishes across a lot of all these areas, but it really does feel like this is a particularly exciting time to be in this precise area.
I wish I was 20 years old.
Yeah.
Just because it gives me this opportunity to work in this area. The next 20 years is going to be fascinating.
Yeah.
And like you were saying about it being multidisciplinary, like just looking at our book series, Smart Grids and Powers come up obviously in our energy series, but also in our communication series and our security series, just because it involves so many people in so many different areas, especially as we move towards more smart grids and that kind of thing. And I'm really sorry to kind of end it here, but we've coming to the end of our time. I won't drag out too long, but thank you both so much for joining me. And I look forward to seeing where the book series and the journal goes.
Well, thank you very much for having me, and look forward to working with you guys.
Yeah.